Hey, Math 8, we're going to do today is the last notes on scientific notation. I think I have some good tips here that will help you with the story problems, which can be a little bit difficult. And I have one new thing to show you a little bit. So let's get started. Let me get the camera set up. Bam. You can see I've already labeled the notes. Section 5.5 continued. And the first thing I want to go over with you is comparing. I like to put a star next to new topics. Comparing numbers in scientific notation. All right, this is an easy topic. We just want to be able to look at two numbers that are in scientific notation and tell which one is larger. Let's write that down. Which one is larger? So here's how you do it. First, look at the exponent on 10. All right, the larger exponent, always the bigger number. The larger exponent is always the bigger number. So you got that. And then secondly, if the exponents are the same, then compare the A values. And that's really it. Let me do a couple examples. So if I had 7.85 times 10 to the 11th, and I had 4.27 times 10 to the 12th, and I want to know which one is bigger, the first thing I do is I look at the exponents, and since this one has a larger exponent, it is a bigger number. It doesn't matter that 7.85 is bigger than 4.27. The number with the larger exponent is always the bigger number. It could be tricky if they're negative. Negative exponent, that is. Scientific notation never has negative numbers. And 7.42 times 10 to the negative 8. So if I look at these two numbers, first thing I want to do is look at the exponents. Negative 5 is a bigger number than negative 8. So 7.43 times 10 to the negative 5th is the bigger number. And then the last example might be 2.93 times 10 to the 9th. And 1.27 times 10 to the 9th. And in this case, the exponents are the same, so then I look at the A values, and the A value is bigger in the first one, so it's the bigger number, right? Pretty easy to look at two numbers in scientific notation and tell which one is larger. All right, besides that, I have one big tip for you when doing story problems. And here is my tip. Use the 6-2 rule. Now, what is the 6-2 rule? So here's the thing. In story problems, one of the difficult parts is trying to figure out what operation to use on the numbers in scientific notation. Should I add, subtract, multiply, divide? So one way to figure that out is this thing I call the 6-2 rule. The 6-2 rule says, put 6 into the problem for the larger number. Put 2 in for the smaller number. Okay, so we're putting 6 in for the larger number. We're putting 2. We're going to replace the numbers that are in scientific notation, because sometimes those numbers in scientific notation are difficult to understand. We're going to replace them with 6 and 2. We're going to put 6 in for the bigger one and 2 in for the smaller one. Then, reread the problem. And when you reread the problem, you can often just figure out the answer. Figure out answer. When the numbers are 6 and 2, it's usually pretty easy just to figure out what the answer is. And then figure out what operation on 6 and 2 gave you the answer. Like, if you figured out the answer was 3, well, then you must have done 6 divided by 2. Or if you figured out the answer was 8, you must have done 6 plus 2. I'm telling you, when you read the problem with 6 and 2, you can often just see what the answer must be. And then use the 6 and the 2 and figure out what operation gives you that answer. Then use that operation on the actual numbers. Go back to the numbers in scientific notation and use that operation. So I've got a couple examples for you. Okay. So here is one that I printed these right off of Delta Math, and this is one that is often gives us trouble. So it says the size is typically found by capturing an image under a microscope, then using software to measure its diameter. 2 cells are measured using this method. So I have cell C and cell D, and here's their size. Now, how many times larger is the diameter of cell C? So it seems like it's a times problem, but look again. When I replace these numbers, now which one is bigger? Well, cell C is bigger because it's got the bigger exponent. So I'm going to put a 6 centimeters in for cell C, and I'm going to put a 2 centimeters in for cell D. And I'm going to reread the problem. So I've still got this part up here which tells me the size of a cell is typically found, and here are the sizes. How about that? There's the bell. How many times larger is cell C than the diameter of cell D? How many times larger is 6 than 2? How many times larger is 6 than 2? Well, 6 is 3 times 2, right? 6 is 3 times 2. The answer is 3. It's 3 times larger, right? Okay, so now that we know the answer is 3, what operation on 6 and 2 gives you 3? If you add 6 and 2, subtract, multiply, divide. If you multiply, you get 12. But if you divide 6 and 2, that gives you the answer. And now that I know I'm supposed to divide, go back and use the actual numbers and divide. This is 1.18 times 10 to the negative second divided by 2.34 times 10 to the negative third. And how do I divide numbers in scientific notation? Well, I divide this part, so let me do that. 1.18 divided by 2.34. And that is a yucky number. Ooh, I don't like it. Ooh, I'm supposed to round to the nearest tenth. All right, so I got 0.5042, and I'll stop there, times 10 to the, and when I'm dividing, I subtract. -2 minus -3. That equals 1. My answer is 0.5042. Now, I can answer this in standard notation. So, I'm going to go ahead and move the decimal one spot and put this in standard notation. It would be 5.042. They told me to round to the nearest tenth, so that would be one decimal place, and the 4 is telling me to keep the 0 the same. This would be 5.0. All right, I want to try one more, at least. I think this is a very good one. Okay, so again, this is one of those mixed word problems right off of Delta Math. It says the distance from Neptune to Earth is 4.5 times 10 to the 9th kilometers. How long would it take a rocket traveling at 5.38 times 10 to the 4th kilometers per hour to travel from Neptune to Earth? Round your answer to the nearest whole number. Okay. So the first thing I'm going to do is I'm going to replace these crazy numbers with 6 and 2. Guys, this 6-2 method, I'm telling you it works. I'm putting 6 in for this one. I'm putting 2 in for this one. So it tells me the distance from Neptune to Earth. Right now I'm going to reread the problem. The distance from Neptune to Earth is 6 kilometers. How long would it take a rocket traveling 2 kilometers per hour to travel from Neptune to Earth? All right, so it goes 2 kilometers per hour. How long would it take if it had to go 6 kilometers? Well, if it goes 2 kilometers per hour, then it would take 3 hours to go 6 kilometers. The answer is 3. Ooh, just like the last problem. So what operation gives you an answer of 3? Again, this is a division problem. And now that I know it is a division problem, let me go back and divide the actual numbers. 4.35 times 10 to the 9th divided by 5.38 times 10 to the 4th. And so I'm going to divide this part. 4.35 divided by 5.38. I get 0.808, and it keeps going, but that's far enough. Times 10 to the, and when I'm dividing, I subtract the exponents. 9 minus 4, that's 5. This is 0.808 times 10 to the 5th. So, you know what? Because that's a 10 to the 5th, I'm going to want to go farther with this decimal. I don't know if you did it with me or not, but I'm going to write more of it out. 50186. That is the whole decimal it gave me on the calculator. So, I need to move it 5 spots, I guess, because I'm rounding to the nearest whole number. 1, 2, 3, 4, 5. This would be 80855.0. Hours. That's how many hours it's going to take. That is 80,855. And I've done it. Okay. I hope that 6-2 method helps. Come ask me questions if you got them. I will see you guys tomorrow.